Thanks to Geshe Lagdor and Dr. Bryce Johnson for inviting me here in a forum where there is a dialogue between Buddhist monks and scientists. So some people might wonder, being a scientist, why I am here or why monks are here. And for last 2 days, lot of discussions are going on similar to these issues. So my own thinking is that we scientists, especially the physicists, because I'm telling physicists because I think most of the physical phenomena in the universe can be explained with the laws of physics. So physics is most fundamental of all the physical sciences. And we are looking for ultimate reality, but we are in the process. We have not reached yet any unifying theory of universe. On the other hand, the Buddha, the Sanskrit meaning is who is enlightened, who has reached to both, means enlightened persons, means who has experienced ultimate reality. So the masters who experience ultimate reality, they discussed or they analyzed kind of epistemological or ontological issues which is prevalent in all the physical and biological phenomena in the universe. So I thought that if we present our most recent results in neuroscience or physics and the problem, epistemological or ontological problems we are facing to the Buddhist scholars or Buddhist monk, they might be able to tell us the issues how, in the Buddhist perspective, they discussed or they analyzed. In a way, both of us might be benefited. I can give you one great example. Heisenberg, who is the discoverer of uncertainty principle in quantum theory, after discovery of quantum uncertainty principles, he was a little bit confused and dilemma or feeling discomfort regarding the epistemological issues related to uncertainty relations. So he came to India, he came to Calcutta, not Calcutta exactly, to a place called Shantiniketan, where the famous poet Tagore was staying. So he met Tagore, spent few days, discussed the epistemological issues, and after the discussion, he told, now I feel comfort. Okay, so we are changing the paradigm from classical regime or Newtonian regime to quantum theory. So we have newer and newer epistemological problems, and so is in neuroscience. So in my talk, what I'll try to express that what are the issues coming from modern research in neuroscience and what are the epistemological issues might be interesting to the Buddhist scholars and Buddhist monks. And in that way, it might be possible to make a dialogue between the two communities. Before beginning of my talk, let me say a few words regarding the methodology. The methodology the scientists in physical science we use is up till now is different rather than the methodology used in consciousness research or even brain research. Because what we do, we construct a theory like Einstein constructed the general theory of relativity, or quantum theory was developed, and it should be a meaningful physical theory only when the results can be tested experimentally. Otherwise, you can explain a phenomena in many, many ways, but unless it has a predictive power, the theory is not acceptable to the community. In that sense, I can mention string theory is still is not acceptable to the physicist community because its prediction is not yet verified. The billions of dollars has been spent to verify its prediction. Okay, so but in neuroscience or in brain research or consciousness research, people are finding, or even genetic research, people are finding a kind of association or correlations between the activities in biological systems and our physical laws or the events we are observing. But we need to change this methodology. And in fact, uh, new technology is being developed or they are in the process of developing. Suppose somebody says that we have a particular type of feelings, and if you take MEG recordings, then you can see that some portion of our cortex might be activated, and we say, well, there is a correlation or association with our thoughts and the neuronal activity. Fine. This is one way. But what people are thinking now, very seriously, that is it possible to put some kind of electrode or some other means to activate the neurons in those regions of brain so that you might have a feeling like you don't need to go to see the television and say, oh, I have seen a really good picture. It's called virtual reality. But the technology is still in its infancy and some developments have been already done, but this is a big story. I'm not going to tell that story. So today, what I'm going to say that what is the development of modern neuroscience and its epistemological issues which might be related to Buddhist ideas. Now, the first question you might ask, being a theoretical physicist, why I became interested in studying brain science or neuroscience. Okay, uh, there is a famous statement by McCullough from MIT. He was a theoretical physicist and became neuroscientist. So his famous essay is Why the Mind is in the Head. He writes, the term mind, I mean ideas and purpose. By the term body, I mean stuff and processes. Stuff and processes are familiar to every physicist as mass and energy in space and time, but ideas and purpose he keeps only in the realm of discourse and will not postulate them of the phenomena he observes. So the problem is that we have understood the dynamics of the galaxy, dynamics of the stars, dynamics of the planetary system. It is in the very large scale. We constructed another theory called quantum theory to understand the behavior of the microparticles like electrons, protons. So, and we, the human being, we are in the middle. I'll show you a picture in the scales where we stand, but with a huge complexity. So the problem is that whether we can understand the complexity of the animals or human being in terms of the laws of physics. This is the only debate is going in 21st century. So even some famous neuroscientist, Rudolf Linus, he is propagating the idea that neuroscience is the only science. I will explain why he talked about why neuroscience is the only science. Okay, so let me show you where we stand. Yeah. Okay. If you look at the picture, we human beings are here, and these are subatomic particles, tracks of the subatomic particles. On the right side, you see these are galaxies and cosmos, and this is the scale. So we are here almost in between the two worlds, but we have enormous complexity. So now, how to understand this complexity in terms of the physical laws? This is the debate. So let me first tell you what is my plan of today's lecture. You might ask, okay, I am going to tell something about self or qualia or kind of consciousness. So why I am talking about brains? Yes, this is a good question. The famous neuroscientist Carl Pibram, we spent many years together. He used to ask me, Sisir, tell me, where is my mind? Is it something outside my head? And that's the question puzzles many, many neuroscientists and other physical scientists. So, what is the starting point? Being a scientist, I should have a starting point. I'm working in the labs. So, like in physics, we start with atoms, molecules. You just take aggregate molecules, atoms, get macro object or material object. So, that's the starting point. So, what's the starting point here? The basic unit is a nerve cell called neurons, and brain contains billions of neurons which are active for different functionings. So that's why I have started my discussion with the discussions in understanding the brain function. So first one is functioning of brain, and there are two worlds called internal world and external world. Means the world outside of us, that is called external world, and internal world by which is recognized the external reality. And then I will discuss sense-dependent geometry, self and self-awareness. Sense-dependent geometry, this is speculate or not speculated. This was discussed by famous physicist philosopher Ernest Mach, who had great influence on Albert Einstein. He has a famous book on analysis, sensation analysis and geometry. So he specifically he coined the term, this is called Hindu geometry, because it is inductive geometry, in contrast to Greek geometry, which is deductive. And I think I need a kind of dialogue with a Buddhist scholar regarding this kind of geometry also. I will explain what this geometry means. Then I will go to modern neuroscience, self, and philosophy of Tsongkhapa, the great Tibetan master. And then, as this is a workshop on cosmology and consciousness, I should also say something how this kind of brain function or self or consciousness is related to the two world, microscopic world, on the other hand, the macroscopic world we call cosmos. Okay. Now, in the beginning, let me say something about representation and reality. You know the famous allegory of prisoners by Plato. Plato told that you place a group of prisoners in the cave or in the prison, and the rule of the game is that the prisoners cannot turn around what is going on their back. They have to look only on the front, and there is light on the back. So what they will see? They will see only the images. So their whole life, what they will think that world is full of only shadows. This is called Plato's allegory of the prisoners. So then what is the reality, or how you can distinguish the true in the quote reality from the fake? So there exist two worlds: world as constructed world in our minds, made by our experiences and genetic predispositions; another world as the domain of things in themselves. So, what is the issues in representationalism? In Buddhist paradigm, they have a long debate on representationalism. So the issue is, what is the relation between perceptual entities and physical objects caused by external objects? I am looking at the flowers, and then the information is being processed by central nervous systems, and I say that this is the rose or another kind of flower. Now, what is the problem? One of the major problem of the perception is that called problem of time gap. So, what is that? The problem of time gap, it comes like this way. You just drop a stone and you take different time sequences of the falling of the stone. You take on particular instant of the stone at a particular height, and then light comes to your eyes, and the receptors will be active and it will be propagated, come through your central nervous systems. And now the issue is that when the information from the receptors is propagating through channels called axons, there are many, many axons, and the axons have various diameters. So the ions which are propagating because of the light falling on my retina, they have a different conduction speeds. It means in the nervous systems, we have the information propagating in different times. So there is a time gap. But we are looking at a particular instant. So how brain recognizes that the object at that instant? This is called time gap problem. And in the language of neuroscience, it is known as problem of simultaneity. And physics also, we discussed the concept of simultaneity in relativity and most of the modern physics. So, firstly, I will tell how we in neuroscience solve this time gap problem. Then I will go what is the views of Buddhist scholars. So, the neuroscience, they discovered, I mean, from experimental point of view, they said that there exists a particular rhythm called 40 Hz oscillations, which is responsible for our conscious states. And this exists both in awakening state as well as in dream state. So this existence of 40 Hz oscillation, it implies that there exists a quantum of time which is 10 to 14 milliseconds. This anybody can calculate from the spectrum of this 40 Hz type of oscillations. Now, if you look at the time gap, I mean the different information propagating through actions coming to the same location called nervous systems, the time gap is exactly 10 to 14 milliseconds. So we have an instrument which has a resolution power of 10 to 14 milliseconds, and we cannot resolve the two instants. That's why we are getting simultaneous events. So that way, the neuroscientists, they solve the problem of simultaneity. But let's see what is the situation in neuroscience, in Buddhist perspective. Okay. Among the Buddhist philosophers, the time gap problem becomes different. Different in the sense that objects and perceptions are momentary, so they can never be simultaneous. How can we then apprehend things if they have ceased to exist when we perceive them? This has been discussed by Dharmakritti and his followers in many, many conflicting solutions. So I will invite the Buddhist scholars to shed some lights on this issue. I tried to read Buddhist text, but I don't know Tibetan language or Pali or not well Sanskrit. So this is one of the big issues from the Buddhist perspective. Now, what are the Buddhist views on representation? We call common sense view of perception. One is an awareness directed to an object, and perception, another is perception is a result of contact with external reality. Even this tension is found in Dharmakritti's account of non-deceptiveness of valid cognition. Now the former emphasizes the presence of the object to cognition, whereas the latter stress the time gap between object and the subject. Chaba and his followers emphasize the former, whereas Dharmakritti and his Shagya interpreters the latter. So I like to listen, maybe in the panel discussions or sometimes from the Buddhist scholars. So what is the real situation or how they solve the issues? Now, I am going to deeper issues like what is the main function of the brain? Main function of the brain, the prediction is considered as the ultimate function of brain. So what is meant by prediction? We mean prediction is a forecast for what is likely to occur. Suppose you are playing ping pong ball. So ball is coming, but you have to push your net such that it exactly strikes the ball at the right time. So this is a kind of predictions. Or you are moving in a road and a car is by accidents, it's coming towards you so that it might kill you. But immediately you just jump to the footpath and you saved you. So this is a kind of predictions. But I do not think that brain calculated the speed of the vehicle, the time and details, so that within seconds brain can say, oh, well, within that particular duration car will come in that direction. So I don't think brain does this way any type of calculations. And I'm going to show you, giving heuristic arguments, that brain does not do in a digital machines. It's more like a analog machines. I will give you more concrete example later on. And then there is very, very interesting phenomena called motricity and prediction. So what is motricity? Motricity is nothing but active movement. I mean, apart from sensory input, we have the motor output. Like a mosquito just sits on your face, your hand goes and slaps. So it's a motor activity. Or blinking of the eyes, it's a motor activity. So we say that active movement is nothing but we call motricity. And motricity plays very important role in prediction too. And finally, in self-awareness. So Linus, he calls that which we call thinking is the evolutionary internalization of the movement. Only organisms that move have brains. So the plants, they do not move, and we say they don't have brains because they don't have nervous systems. So according to this proposal, we say only the entities which move, they have the brains. And the entities who don't move, they don't have brain, so they don't have nervous systems. So prediction. So let us consider an example of what is really prediction. Okay, suppose let us consider that there is a carton of milk in the refrigerator and we are going to pick up the carton of the milk in the refrigerator. So what happens? In reality, a movement such as reaching in the refrigerator is considered a simple one, but no, listen. From a functional perspective, even a simple movement often engages most of the body muscles, resulting in an astronomical number of possible simultaneous or sequential muscle contraction and degrees of freedom. I will show you a very, very realistic example how complex this kind of computation is. It seems it's very, very simple just to go and bring a carton of milk from the refrigerator. So, what is the arguments? Suppose there are 50 key muscles in the hand, arm and shoulder to reach a carton. And now from simple algebraic calculations, you can say that there are 10 to the power 15 combinations of muscle contractions are possible. So this is an astronomical number, huge number. Suppose during every millisecond of grasping sequence, single best of 10 to the power 15 combination is chosen, then 10 to the power 8 decisions have to be made per second. Now, if you think that brain is a computer, then it would have a processor of 1 exahertz, means 1 million gigahertz. We cannot think in any modern computer. So, does brain do this kind of things like computer or not? This is a big issue. Yeah, so let us go further. How does the brain predict? From the nervous system to predict, it must perform a rapid comparison of the sensory properties of the external world with a separate internal sensory motor representation of this property. Once a pattern of neural activity acquires internal significance, the brain generates a strategy of what to do next. That is another pattern of neural activity. This strategy can be considered an internal representation of what is called a prediction imperative. Now tell me, what are the different schools in neuroscience exist? There are mainly two schools. One says that when we are born like a blank slate. And up to a particular age of the child, like 6 or 7 years, there is a learning process happening, and like a photographic plate, all these kind of patterns or forms are being stored. So, as we grow up, then as soon as there is a stimulus from outside world, it tries to match it with the internal patterns. So this is the one school say like this. But the issue is how the initial patterns are being stored. If we have a kind of potentiality of storing these phenomena, then how can you think of that? So we have a different propositions. So we called a functional geometry or dynamic geometry, where this kind of learning has a different meaning. Okay. Now, let me go directly to what is self. This is the dictionary definitions. I mean, if you go to, if you find any dictionary, then they have a lot of statements regarding self called total, essentials, or particular being of a person, the individual, the personality, character, individuality, individual's consciousness of his own being, identity, subjectivity, ego, etc. So this is the dictionary definition. But let us go what we think in terms of the brain function. So we called it neurology of self. So we say that self is the centralization of predictive imperative. What is meant by that? Here, prediction, brain predicts a particular event. Well, if there are many type of predictions exist at the same time, or suppose brain predicts a particular event taking particular duration of time, and then if there is other type of prediction, it takes another duration of time. So you have a different time durations you needed for the different predictions for the same events. Now the problem is that brain optimizes, and they say brain optimizes it so that there is a one-time predictions. There are not many type of predictions for the same events, and we call it the self, which binding this kind of phenomena of predicting one, minimizing its or kind of optimizations. So prediction is not a localized phenomena. The neuronal circuits, you cannot pinpoint which particular neuronal circuit is responsible for the self, but it is distributed over a particular region, and this is a particular mental state. We call this abstract entity, we refer as I or self. And according to this view, self can exist without even awareness of its existence. What it mean? Suppose there is a fire in this hall. You say, run, but you are not saying, I am running. So you have awareness, but you don't have awareness of self. Let us go to, again, the debate, Sankhopa and self. According to Sankhopa, there are two senses to the term self: a self conceived in terms of an intrinsic nature that exists by means of intrinsic being, and a self in the sense of object of a simple natural thought, I am. Of these two, the first is the objection of negation by reasoning, while the second is not negated, for it is accepted as conventionally real. For Sankhopa, whether or not self exists is not merely an epistemological question, nor is it solely a therapeutic one, it is an ontological question as well. That is to say, it is a question of regarding ontological status of person. Sankhopa understands the concept of self to be highly complex with degrees of reality that are constructed at different levels of our thought processes. So here also I invite Buddhist scholars what is their understanding regarding self. We are saying self is nothing but a particular mental state of the brain. And there are debates going on for many, many centuries regarding self-awareness in Indian and Western traditions. Here, when we say Indian tradition, this includes also Buddhist schools. The theories of self-awareness specially developed in two main traditions. One called reflectionist or other illumination, in Sanskrit called Paraprakasha theories, and another reflexivist or self-illumination called Saprakasha theories. And what is the thesis of reflection and reflexivity? The self-awareness thesis, it says, if a subject is aware of an object, then the subject is also aware of being aware of that object. So what are the two theses, reflection thesis and reflexivity thesis? Reflection thesis says self-awareness is the product of a second-order awareness taking a distinct first-order awareness as its intentional object. And the reflexivity thesis, conscious state simultaneously discloses both the object of consciousness and aspect the conscious state itself. Why I am going into details of this kind of debates? Because in neuroscience, people did some experiment and found very, very exciting results which might have relevance to these kind of discussions. Okay, now we are going to another interesting aspect, mind-brain continuum. We say mental activity is nothing but brain activity. This is our propositions. So it means perceiving, thinking, introspecting, and so forth are the activities of the brain. The expression connotes the smooth integration of functional properties at all levels of organizations, from individual cells, neurons, and systems to behavior. Finally, it reflects the profoundly important fact that human brains evolved from the brains of preceding animals, sharing much with them structurally and functionally, as well as cognitively. Assuming mental activities are brain activities, it is in the factual details, the details of anatomy, physiology, neurochemistry, developmental neuroscience, and psychophysics that the truth is to be found. Now, the subject-object continuum and Chittamatra school, there is a debate in among the Buddhist scholars. So in Madhyamaka Chandrakirti, he discussed the concept of other dependent as the most fundamental of three Chittamatra nature, as if without either subject or object, the other dependent existed empty of duality, then by what would its existence be known? It makes no sense for it to exist unapprehended. Chandrakirti begins the arguments by pointing that if there is no subject of this duality in the other dependent, then from the perspective of one apprehending reality, there would be no awareness of it, since the very structure of subjectivity is dualistic. And in his commentary, Chandrakirti Mifam critically analyzed the arguments of Sankhopa on the subject-object duality and reflexive awareness. Now, if you look at the results of neuroscience, in vitro experiment, it is found that brain is considered as self-referential systems. I am not going into details. If anybody is interested, I can give you neuroscience papers published in Proceedings, National Academy of Science, USA, Nature, and other places. So you can look. So now the Buddhist scholars, they can compare their debate with the findings of neuroscience. Now let us talk a little bit about philosophy of perception. So what happens? I mean, we want to gather information from the outside world is through our physical senses. My previous speaker, he talked about senses and how information is coming through those senses. But what he did not speak explicitly, that how the information is being interpreted by brain. Brain does not only process information, but it interprets also. Suppose information is coming from the flower, but brain says, okay, this is red, or this is rose, or this is another kind. So this kind of interpretation you need it. I was going to ask him what Abhidharma says about nervous systems and interpretation problem. But well, we might have enough time. And post-Cartesian philosophy distinguishes three positions on the nature of perceptual experience: direct realism, representationalism, and phenomenalism. Although these positions do not necessarily exclude each other, they represent three distinct strategies adopted by Indian and European thinkers to explain the perception of this object. And there are two fundamental divisions: cognition as an aspect, called Akar Badu, and the other who deny it. The first view says that cognition does not apprehend the object nakedly, but through an aspect. This view is known as Sakar Badu, propounded by Sankhya, Sautantrika, Yogacara school. According to Dharmakirti, consciousness does not apprehend external objects directly, but only through the mediations of aspects. To be aware of an object means to have a mental state that has the form of this object and is cognizant of this form. Now, how we do it here in neuroscience? Okay, we say that a central issue in brain function is the internalization of the properties of the external world into an internal functional space of the neurons. By internalization, we mean ability of the nervous system to fracture external reality into sets of sensory messages. I mean, the firing of neurons and patterns of firing of neurons. And to simulate each reality in brain reference systems, we call this as dynamic geometry or functional geometry. Why we call dynamic geometry? We call dynamic geometry since the very minimal time resolution or quanta of time associated with 40 Hz oscillation, which is responsible for conscious state, is considered to be responsible recognizing external events and generating the concept of simultaneity. So, we have an instrument which has well-defined finite resolution, and hence we consider only the operational definition as working hypothesis. So, in our view, we have no observer-instrument separation, and internal space is determined by the dynamics associated with the instrument-observer continuum. So, this is not Cartesian duality. Okay, now we are coming what I told in the beginning, Greek and Hindu geometry. I have not coined the term Hindu geometry. Ernest Mach, he coined the term Hindu geometry. He says that there might be geometry which is inductive and sense dependent. And he told it is Hindu geometry. And on the other hand, Greek geometry is deductive geometry. So now, again, my question to Buddhist scholars, do you have any thoughts related to this kind of geometry, which is much required understanding brain function, which is not deductive geometry at all? Okay, now in functional geometry or dynamic geometry, we have many patterns, infinite number of patterns stored in the geometry, and during the birth, it is maybe coming through genes. And what happens when there is a stimulus from outside world comes? It just modulates. What do you mean by modulation? Like if you think a musical instrument, and like a violin, or like a sitar or sarod, and you can modulate the strings so that a lot of harmonics and other things comes out. So our brain is nothing but like a musical instrument. When there is a stimulus, it just modulates it. And there are infinite number of patterns are stored there. So one pattern is coming out because of the suitable conditions. Now there is another aspect of consciousness called intentionality. Prediction, we discussed about prediction. So prediction must have a goal. Otherwise, it is not referentially based on anything, and purposeless movement is not only wasteful, but can be made quite dangerous as well. So the goal or object of movement must be well defined, and we may define it here as that which one intends to do in relation to that object or goal. So intentionality is another aspect of consciousness. And then comes qualia. Yeah, this is one of the major issue of debate among the philosophers and modern neuroscientists. So what is qualia? Qualia refers to the quality of entities. Quinn used the term to denote the feeling character of sensation. Let me use the term qualia to denote subjective experience of any type generated by the nervous system like pain, color green, etc. And there are two similar beliefs concerning the nature of qualia. One, qualia represent epiphenomena that is not necessary for the acquisition of consciousness. And second one, being the basis of consciousness, qualia appear only in the highest life form, suggesting that qualia, a recently evolved central function that is present in only the more advanced brains. Now, what is the neuronal basis of qualia? Then I'll go, what is the Buddhist perspective? So, the neuronal basis for qualia, what is the movement or motricity? I told what is the definition of motricity is always the product of muscle contraction and the electrical activity of motor neurons into actual muscular contraction occur in nervous systems. I mean, in reality, it happens. Now, by analogy, somebody might ask, what is the apparatus for endpoint expression for sensory experience? And they say, it's the qualia. So here we say that this qualia is a kind of manifestations or associated with the functional state of the brain. So there are a lot of philosophical issues related to this. We face a serious philosophical problem in our framework, not in Buddhist framework. We consider the geometric or functional state is a sensation itself. But what this definition we face, what we have yet to understand, this is probably not true because the neurons fire, they have a pattern of electrical activity and maybe that gives rise to sensation. So we need to understand, okay, and what is the Buddhist view of qualia? In Buddhist philosophy, probably there is no such single term for qualia. Pain is a type of vedana or redness would be shanna. So now pain, I can tell you, maybe I am taking few seconds more. Pain, some neuroscientists ask one Buddhist monk, Richard Mathurika, that can you create pain in your meditation? He said yes, he created pain without any pinching. And they recorded with MEG technique, yes, there is a particular region of the brain which is active for that kind of pain. So pain is a functional state of the brain. It's no more a kind of subjective thing. Okay, now we are going to cosmos, living organism and microscopic world. Now people will ask, well, is it the unique feature of human brain, this kind of functional geometry? Or in the large scale, there exists that type of geometry? This is very, very interesting questions. And really we found that even in the very small scale, we developed a kind of network, interdependent network, from which all the space-time continuum can evolve. And we published all the mathematical results and philosophical implication in a recent book last year from United States. So we say that this type of functional geometry is not very unique for living organisms, but the question is that in the same time, the outside network and internal network is both evolving. But why this peculiarity? We say subjectivity or qualia for only living organisms. Why not for the outside world? So that might be the mystery. And we don't know yet. We are working what is the transformation from external geometry to internal one. So I don't have much time, so let me finish with self and reductionisms. We are not reductionist in the sense that we are kind of monist. We are looking for unifying principles. We are not reducing just to neuronal activity and all these things. So we have published the paper Predictive Imperative as the basis of self-awareness in Royal Society Journal, and there are other references. So thank you for listening.